Okay, so today we're going to talk about Blackboard Assignment 8, which is introducing us to Lesson 2, where we're going to talk about functions of any angle. So this is going to be Part 1. Part 2 is going to be part of our next Blackboard assignment, assignment number 9. So in our first lesson, we worked with only acute angles and right triangles. So today we're going to talk about angles, and we're going to look at angles that measure greater than 90 degrees. And what I mean by that is when we were dealing with right triangle trig, I'm going to try to slide this up so I can just kind of show you. We were only dealing with trig functions in right triangles. And because we had a right triangle, the two interior angles that we would have, we know are going to be acute, which means less than 90. So today we're going to look at angles bigger than 90 degrees. So to start us off, there's going to be a couple of vocab words that I want to make sure that we're all on the same page with. The first is, an angle is formed by two rays that have an endpoint called the vertex. Many of you have heard that vocab word before, but I want to make sure that you guys know that when two rays come together, and two rays are basically just a line with one arrow on the end. So when two rays come together, the corner or point in which they meet is called the vertex. To generate any angle, what we're going to do is fix one ray. So we're going to take one of these rays and we're going to fix it, which means it doesn't move. And that fixed ray is called our initial side. So one ray, which is fixed, meaning it doesn't move, is called our initial side. Then the other ray that we have in our angle, we're going to route the other ray around the vertex, and this other ray is called the terminal side. So we have two rays that come together at a vertex. The one that doesn't move, that's going to be in standard form on our x-axis. We'll talk about that in just a second. That's going to be our initial side. And then the one that moves around our coordinate plane that gives us different angle measurements, that's going to be called our terminal side. In a coordinate plane, an angle whose vertex is at the origin, and you can remember the origin is the point where our two axes meet together, that's point 0, 0. So in a coordinate plane, an angle whose vertex is at the origin and whose initial side is on the positive x-axis is in what we called standard position. Okay, so off to the right-hand side, I gave you guys two, your x-axis and your y-axis, that we're going to call. So I'm going to call this guy up here y, and the axis off to the right is obviously our x, horizontal, vertical. And our two lines that come together to make our coordinate plane, we know that obviously the point where they intersect is the origin. I'm going to put a big dot there. That's going to represent our vertex. So to start off in standard position, I'm going to do this in a thick line. The ray that is on our positive x-axis, so it's fixed on our positive x-axis, so you guys know that this is going to be our initial side. So our initial side. Then from our vertex, the other ray, and I'm going to put this off in our second quadrant, we know this to be our terminal side. And we know it's in standard position when it looks very similar to this, which means our vertex where they join is at the origin, 0, 0. Put a V there for your vertex. Your initial side is on your positive x-axis. And of course, your terminal side is somewhere in the other four quadrants or on our axes. To start off, I remember talking with you guys a couple weeks ago about geometry, and I know that you guys have dealt with angles in geometry. So going back, there's a couple key things I want to make sure we're all aware of in terms of angle measure, just as a reminder. So when we start off, when our terminal side lays on top of our initial side, so we're starting off with our two rays on top of each other, we are at 0 degrees. If we go from 0 degrees straight up and down, so kind of like that where my pen is, we know that this right angle that's formed is 90 degrees. If we keep going around to our next axis, we get 180 degrees, We move all the way straight down, we get 270 degrees. If we go all the way around a full circle, we're back to 360 degrees. So 0 degrees and 360 degrees share the same position on your X and Y coordinate plane. And we'll talk a little bit more in a couple minutes about what that actually means. They're actually called a certain type of angle. Couple key things about angle measurements. The first is the angle measure is always positive if the rotation of its terminal side is counterclockwise. If you remember, counterclockwise goes against your normal clock. So since your clock normally goes this way, counterclockwise obviously goes that direction. Counterclockwise. Okay. Your angle measure is always negative, or goes in the negative direction, if the rotation is clockwise. So if we're going this direction, like a clock, it's going to be negative, counterclockwise, positive. So in example 1, they want us to draw an angle in standard position. They're giving us 2 angles that they want us to draw in standard position. And in both of these, they have a solution off to the left-hand side that kind of gears us and helps us along in drawing these angles. So the first thing is we want to draw 160 degrees in this X and Y coordinate plane. So to start us off, 160 degrees. So if we just go over here and graph it, we know that starting out we have 0 degrees, 90 degrees, 180, 270, and back to 360. So if we're looking at 160 degrees, in standard position means we obviously have our vertex at our origin. Our initial side is on your positive x-axis. And that terminal side is now going to represent 160 degrees. Since 160 degrees is positive, we know that we're going to be going in our counterclockwise position. We also know that 160 degrees is actually 70 degrees more than 90. So 70 degrees more than 90 actually puts it in quadrant 2. So the terminal side is 70 degrees counterclockwise past the positive x-axis. Just to fill that in. So if we were just to kind of guess, we could call this, so this is going to be an extra 70 degrees. Actually, it would be a little bit closer. We can call this whole thing here 160 degrees. To be honest, it would actually be a little bit more closer to the, so we won't count this one. So the outer arrow is a little bit more accurate about where 160 degrees would be. Therefore, we know that this angle measurement between the 160 degrees and the 180, this degree right here should actually be 20 degrees, so that they all add up to this whole straight line, 180 degrees. So let's look at letter B. Letter B asks us to graph the angle negative 115 degrees in standard position. So again, we're going to start out with our vertex at our origin, our initial side on our positive x-axis. And since this angle is now negative, we know we're going to be moving in the clockwise direction around this way. So another way we can look at this is we started off with 0 degrees, 90, 180, 270, 360 in the positive counterclockwise direction. If we go clockwise direction, we can actually label it the same way we did above, where this is going to be 0, this is going to be negative 90, negative 180, back around to negative 270, and back around to negative 360, if we wanted to go in our clockwise direction. So since negative 115 degrees is negative 25 degrees more than negative 90, so we have negative 90, we know that we're going to be about 25 degrees, a little bit more to the left. This whole angle measure can represent your negative 115 degrees. So it's negative 25 degrees clockwise past your negative x-axis. So that's how you draw angles in standard position. So So let's move on to our first checkpoint. I'm actually going to let you guys do checkpoint number 2 on your own, but I want to look at number 1 really quick because number 1 is going to lead us into the next example we're going to do together. So if we wanted to draw an angle in standard position that is 480 degrees. So 480 degrees we know is more than one full circle around our X and Y coordinate plane in the positive direction. So we know we're going to be going counterclockwise. I'm going to put an arrow going counterclockwise to remember or remind us to be going counterclockwise. So we also know that 480 degrees is one full circle all the way around because one full circle is 360 degrees. So to get an idea as to where 480 degrees is, we're going to start with our vertex, our initial side. One full circle is 360. So if I subtract 360 degrees from 480, 480 minus 360 is going to give me 120 degrees. So one full circle all the way around on top of 120 degrees. Well, where would 120 degrees be? Well, since I know that this perpendicular angle is going to be 90, 120 degrees is just 30 more degrees than the 90. So I know it's going to be somewhere over here, where this full swoop of my angle represents a full 360 turn. And then I obviously add the 90 on top of the extra 30. So this would represent 480 degrees. If you notice, 480 degrees takes one full turn around my X and Y coordinate plane, and then a little bit more than 90 to fall almost in the exact same position as 120 degrees. So if I didn't have my little swoop or my little kind of curve angle going on in the middle, 480 degrees and 120 degrees actually share the same position in my X and Y coordinate plane. So if I didn't have this little squiggle in the middle, 480 degrees and 120 would look exactly the same. And because of that, because 480 and 120 share the exact same position in your coordinate plane, we are going to call these two angles, 480 and 120, coterminal angles because they coexist, your terminal sides coexist in the same position on your X and Y coordinate plane. So that's why we wanted to work on number 1. It's going to lead into what example 2 is. So I'm going to let you guys do number 2 on your own. We'll talk about that the next time we get together for class. So coterminal angles. So in checkpoint 1, 480 degrees and 120 are what we call coterminal angles. And again, coterminal because the terminal side coexists in the same position in your X and Y coordinate plane, meaning they look exactly like the same angle. They lay right on top of each other. Okay? Any coterminal angle with the an angle coterminal with a given angle can be found by adding or subtracting multiples of 360. And that's what we're going to talk about in example 2, finding coterminal angles. So let's move on to example 2. We're going to fill this piece in down here in a couple minutes, but I'm going to just kind of have you focus just on A and B. Actually, more importantly, just letter A right now. So negative 55 degrees, and I'm just going to sketch it. You don't have to do this every single time, but I'm going to kind of sketch what 55 or negative 55 degrees is going to look like. So negative 55 degrees, if I start off at 0, I know negative 55 degrees is going to be a little bit more negative than halfway between 0 and negative 90. So since halfway would represent negative 45, negative 55 is probably going to be just a little bit more negative or a little bit more closer to that negative 90 degrees than halfway. Okay, so this is negative 55 degrees, this angle right here. So we want to come up with a positive angle and one negative angle that would give us an angle that would almost coexist in the same spot, meaning your angle is going to look very similar to this, exactly like this actually, but it's going to have a different angle measurement. So two other angles that coexist in the same spot, so it's going to look very similar, exactly like this, off to the right-hand side. So how we do that is we add or subtract multiples of 360. So to start out, to add or subtract multiples of 360, if I take negative 55 degrees and I add a full circle, so I'm adding 360 degrees. So multiples of 360 can be 360, it can be 720, just multiples of 360. So I'm going to just add one full circle around. So negative 55 degrees plus 360, if I plug that in my calculator, gives me 305 degrees that would be representative of this exact same angle. So let's look at that real quick. 305 degrees. Adding 360 to it. So starting off 300, so if we were to graph 305 degrees, we would also start off here. We would go all the way around. So we would go, so I'm going to take my terminal side, start, so we got 90, 180, 270, and then 270. If we continue through to 305, we would actually get, since this negative 55 right here is representative of the piece that it's not going to count, this whole side right here is going to represent 305 degrees. So in other words, if I started off with my initial side on my x-axis and traveled all the way around counterclockwise and land right back on top of this terminal side, that opposite end, that 300, the opposite angle on the other side is going to be 305 degrees. And you know, if you add these two up, 305 and 55 degrees, you add those two up, you should get a full circle, which would be 360. You can also find other coterminal angles by subtracting multiples of 360. So if I take negative 55 minus 360, which would be a whole circle, I would get negative 415 degrees. So again, I'm going more negative. So if I start off with this angle, go another full circle, more negative, all the way back around, it's going to lay right back on top of those two green pieces. All right, so looking at letter B, I'm not going to graph or sketch the angle 425 degrees. So now we can actually do this. Now that we kind of get the concept, we can do this in multiples of 360 without having to graph it. So the first thing I'm going to do is I'm going to take 425 and I'm going to add 360 because I want a positive coterminal. So if I add 360 degrees to 425, I'm going to get 785 degrees. So negative 55 degrees and 425 degrees and 785 degrees. These are going to be coterminal. I can also subtract 360, but I could also subtract multiples of 360. So let's do 360 first. So if I take 425 minus one full circle, 360, I get 65 degrees. But the directions wanted us to have one positive and one negative angle. So if I subtract one multiple of 360, I'm still at a positive angle, okay? And I already have a positive coterminal angle. So this is okay, but we actually have to do it again because we want a negative angle for coterminal. So how we could initially have done this, since 425 is more than one full circle, I could subtract it by a multiple of 360. So 360 is obviously one circle around. Two circles around would be 720, which would just be 2 times 360. If I take 360 times 3, I get 1080 degrees, and then that just continues on, because I can just continue around my x and y coordinate plane in infinitely many circles, full circles around my coordinate plane. So if I take another multiple of 360, which is 720, 425 minus 720 is going to give me negative 295 degrees. So you can take one of these positive coterminal angles and this negative coterminal angle, and they would both be representative coterminal angles of 425 degrees. So at this point, we covered both example 1 and example 2 of functions of any angle. So in our next Blackboard assignment, in our next videos, we're going to talk a couple more examples and get into a little bit more depth about these triangles that are greater than 90 degrees. So at this point, I'm going to have you guys stop. You guys can work on checkpoint number 2, and then you can pick up with checkpoint numbers 3 and 4, and of course the now you try is numbers 1 through 6 at the bottom. And the next time we get together, we will go over the answers and any questions that you may have on Blackboard Assignment 8.